Fellowship at SUNY, USA. Developing therapeutic peptides and advancing plant-based and anti-inflammatory formulations, reflecting her strong commitment to innovation and societal impact. Little Flower welcomes you, ma'am.
Thank you for such a wonderful introduction and a very good morning to all of you today, respected delegates who are attending and participating in this conference, and the faculty of this college and my dear students. It's a very nice opportunity to come and visit you all and talk about our work. So you have seen that my biography mostly deals with immunology and nanotechnology and cancer, but today I am going to speak about something else which has been recently acclaimed in the media and also on several occasions. So I thought since this conference is on sustainability, I should talk about that one today. Recently my student Ramesh, he is from agricultural background. His father is a farmer, and he used to tell me, madam, my father's health is not good. He is always spraying pesticide in the field, and now both his parents are they keep suffering for some of the other health issues. So I told him, see, he actually joined on patenting work, on sepsis work. But because I said, why don't you just do a small project? Let us get the soil from that field and see what are the bacteria in that field, and let us see what happens. Let us see what kind of bacteria are there, because you know that even soil has microbiome, isn't it? Nowadays, microbiome is a big dominant topic of discussion in microbial, even environmental engineering, B.Tech biotechnology. Everywhere the concept of microbiome is coming up. Yeah? Please change the slide. No? Yeah. Huh? Oh, thank you. So, so I thought it will be nice if you understand what are xenobiotics. So I thought I'll speak to you about what are the xenobiotics and how it is actually. I asked Ramesh to get the soil sample, and because that soil sample is from a field which is exposed to large concentrations of pesticide, we wanted to explore what are the kind of bacteria in that soil. Okay, so before we proceed there, let us see what are xenobiotics. Maybe you all know what are, you have an idea what are xenobiotics? Yes, so these are compounds which are not natural and they cannot be degraded easily by the environment or your body, both. Okay, like xenoestrogens present in fuel exhaust. Okay, then plastics. Okay, then pesticides. Everywhere you see, there are xenobiotics. Okay, next slide please. Yeah, next. So, xenoestrogens are part of every company, plastic production, then textile industry, electronics, pesticides. Yeah.
Lights will break the lights.
These also.
Yeah, now it is far better.
So you can see that all areas of our lives we see that there is a problem with contamination with xenoestrogens, right? Next. So you can see that a major part of these xenobiotics are pesticides. Okay, pesticides like organophosphates. So maybe if your parents are farmers, maybe some of you might be from rural areas, you'll find that in villages, farmers use pesticide at 4 times the concentration recommendation, which is recommended. Okay. So because of that, what is happening is these xenobiotics are actually lipid soluble. So easily they can enter your body because your body cells are coated with a lipid membrane, isn't it? Bilayer is there, lipid bilayer. So they can be easily absorbed by our body. And once they are absorbed, they can go anywhere in the body, into the brain, intestines, skin, eyes, you name it. You know, they are there. So the problem is once they come into the soil, they are coming into water, right? Because soil is connected to water also. So you consume that water, you eat crop products which are produced from such soil. So there is magnification of this, xenobiotics. So that is the reason you see more number of PCOD cases, cancer cases. 1 in 4 are suffering with cancer. 1 in 3 are suffering with high blood pressure or any lifestyle disorder. So this is all because of our doing. Okay, we are using things which are xenobiotics explicitly without following proper regulations. Even if we follow with proper regulation, we are not properly disposing them off. Okay, because of which they are basically causing damage to our body, right? So what happens is because they are ubiquitous now, xenobiotics pose a very big problem to our health and also environment. For example, they cause nutrient depletion. They do not allow nutrients to be absorbed by your body. That is why previously if 1 carrot you ate, you will get enough vitamin A. Now it is not like that. You have to consume at least 4 to get the same amount of nutrition. You get hormonal disruptions. That's why depression is common nowadays. PCOD is common nowadays. Right? I'm sure among girls it is becoming very common. Right? Thyroid was hardly known 15-20 years back. But now you see it quite frequently. Then cancer, diabetes, so India is having more than 10 crore diabetics. Yes. Hyderabad is a diabetic capital. You know? So, more than 10 crores. Imagine how much profit pharma is getting from India. Okay.
At what cost?
At our cost. So, our population is our asset. So, always we are a very big market for everyone. Yes? So, all these autoimmune disorders, inflammation, all these are the problems. So, this is a cascading effect in human beings. So, what happens is gut dysbiosis, yeast overgrowth. You see nowadays, a lot of people get yeast infections, skin infections. All these I have discussed previously. So, coming to organophosphates, like I have told you, these are pesticides and these are inhibitors of acetylcholine esterase, which is a neurotransmitter. So, which cleaves acetylcholine. So, what happens is if you inhibit acetylcholine esterase, so you will not have control over your body. Okay, including urination, digestion, depression. Okay, cognitive abilities, everything will be affected. Okay, so this was designed for pests. That's how you kill the pests, by inhibiting the enzyme. But now, because it is amplified, what is happening? It is also affecting our body, right? So they cause hormonal, neurological, fertility-related disorders, and they are potent carcinogens on top. Okay, carcinogen. You know how to test a carcinogen? By Ames test. Ames test, you can tell if a compound is carcinogenic or not. Okay, so it uses an bacterial strain called mutant Salmonella typhimurium. So if that mutant becomes regains its function, which was for which histidine mutation, it means that the chemical tested on this Salmonella is carcinogenic. Okay, it is reversing the mutation. Okay, so that was done by Bruce Ames, who did it at age of 25. He won Nobel Prize for that later. Okay, so that is why you name carcinogenic, means it causes cancer. Okay, and you can test it using many techniques. For example, Ames test. So, like I told you, it causes neurological problems, like it causes nicotinic effects where you get body pains, and it causes muscarinic effects where you lose control over your body movement. Okay, so that deadly is this organophosphate pesticide. And India is consuming, like in the world, we are number 10 in consumption of pesticide. Number 10. Okay. So, like I told you, it has harmful effects on our body, and also it kills local bacteria in the soil. So it also causes disruption of soil balance. Okay, because of this, repeated application causes resistance, obviously, isn't it? If you take ampicillin twice or thrice a year, next time you get infection, it will not work. Am I right? It will promote resistance, and resistance spreads like wildfire in our gut, because we have bacteria equal to the number of cells of our body, trillions, in the gut itself. Okay, so if there are bacteria which are developing resistance, they will spread it to surrounding bacteria also. So that is a problem with multi-drug resistance. So it's deadly, to disrupt gut microbiome balance also. Right? The same thing it does to soil and causes insect resistance, and also poses danger to the soil balance. Okay. Only problem is that there are different types of organopesticides like malathion, chlorpyrifos, monocrotophos. All these have different half-lives. Okay. Do you know what is the length of a crop? Means length meaning how many months do you harvest the crop? Within 6 months, no? Yes. Let's say you applied the pesticide at 4th month. Okay, many pesticides have half-life of 120 days. So before they are finishing their half-life, they are harvested. Okay, they don't wash your grains, no, before supply. Do they wash? Even if they wash, will it go? So they are supplied into the market. So you understand the risk now. In soil, they would have been degraded within 120 days probably, but before they degrade, it comes into the market. So you are consuming contaminated water, you are consuming contaminated vegetables, contaminated grains. Yes. So as a youngster, you should all understand this issue correctly, and how to avoid the negative aspects of this issue. Okay. So coming to organophosphates. So microorganisms in the soil, they help in degrading these pesticides. And what are these pesticides? Usually, I told you organophosphates they are soluble in organic solvents, but they are also soluble in water. That is why you can consume this. Okay, without any issue. And you see, there are so many pesticides. Some of them have half-life of 9 years. Aldrin and dialdrin, they have half-life of 9 years. DDT has 10 years. Now that's why it is banned. People don't use it. But organophosphates have a comparatively shorter half-life, 7 to 120 days. But you understand why still it is a big problem. Yes? Okay, so now in the soil, I told Ramesh to get the soil sample. Right? Because soil has, again, like our body, thousands and millions of types of bacteria. Many of them are sporulating. Okay, and they tend to degrade because organophosphate is a source of phosphate also. Yes, and also carbon. Many bacteria can use it as a carbon source and also survive. So that's what we have observed. I will tell you the next slide. But many pesticides are not degrading. And usually, if you want to make sure that they are degrading, these are the strategies we follow for biodegradation or bioremediation. Okay. For example, intrinsic bioremediation, which is natural. Bio-augmentation, if you add more bacteria to the same soil sample to aid faster bioremediation. Composting, you have a very good idea what is composting. Then bioremediation using bacteria or fungi, even fungi can be used. Then mineralization, by complete breakdown of organic matter by microbes. So all these are very good, and these usually microorganisms release several enzymes and acids that are able to degrade these pesticides. So our weapon mainly is bacteria only, soil bacteria. Because chemically, if you want to degrade it, how much can you do? Because agricultural lands are hectares and acres big, isn't it? So how will you do remediation of soil? Such a large soil sample or area. So it is very difficult. So our best weapon is to use local bacteria only. Okay. So because bacteria have ability to interact both physically and chemically with all the substances they get exposed to. Okay. And they work in communities. There is something called as signaling among bacteria, quorum sensing. Quorum sensing. Okay, where bacteria communicate with other bacteria and work together. Okay, so there are plant growth promoting bacteria, rhizobacteria, or nitrogen fixing bacteria, phosphate solubilizing bacteria, pesticide degrading bacteria, and so on. And they degrade several pesticides using various bioenzymes present inside and break down the pesticides into non-toxic products. And very good thing about bacteria is they are very cheap to cultivate. So we could cultivate bacteria with just minimum salt medium, minimum salt. Just it will be having ammonium chloride, and we added this organophosphate pesticide, bacteria growing. Bacteria can grow very easily. They don't consume much expenditure, right, to make medium. They are often very less expensive. They can eliminate waste permanently. They can eliminate long-term liability once they can be started to be used. They can be easily continued. They will not cause any damage to the soil. They can be coupled with other physical or chemical treatment methods also. So financially also it has very big advantage. Although there are few disadvantages also. Can you read the text at the back? Is it visible? Yes, is the text visible? Yes, huh? Okay. Because I thought that maybe it is small for people at the back, so I just wanted to ask. Anyway, so disadvantages are they take a little longer and sometimes the degradation is a bit partial, it is not complete. So for that you have to find more alternatives. Okay, so coming to the work at our lab. So I told you what Ramesh did. No, he got soil sample and we grew the soil. We took the soil and dissolved in water. You know what is cereal dilution? Yes, have you done cereal dilution? You take soil, maybe 1 gram soil, put in 10 ml water, then you do cereal dilution and you plate them on nutrient agar plates, right? So we did the same thing and we found that and this time to the medium itself we added monoprotophos, which is the organophosphate pesticide. And we grew the colonies and we found there are 4 specific strains which are able to tolerate the pesticide. Okay, so we isolated Micrococcus luteus, Rhodococcus, Bacillus aryabhattai and Ochromobacter intermedium. And what we did was we took minimum salt medium and mixed this back. We cultured this bacteria in minimum salt medium containing organophosphate, that is MCP. Up to 2000 ppm it could tolerate, it could grow, okay, and also degrade the pesticide. That is the main crux of this work. We isolated the strains, we grew them individually, they could tolerate enough pesticide, and we made a consortium. We cultured the bacteria, all of them together with very high ppm of this MCP, and we could observe by HPLC and GCMS that the entire MCP was degraded. So nothing of the MCP was left within 48 hours. Okay, so that is the main work of our lab. And we culture. This is only to show that we optimize the pH at which the cultures can grow, pH and temperature, and we have grown them. And we see these are the peaks which are showing that after you can see one peak shifting. And we showed that after degradation, MCP is gone. And what we did was we isolated genomic and plasmid DNA of this bacteria, and we separated the DNA based after PCR of genes. So what we have done is we know that there are certain genes like NPD, OPD, and so on. So these are the ones which cause degradation of MCP. So we observed that these bacteria have these genes in their genome and also plasmid. In both genome and the plasmid DNA, these genes are present. So that is the possible reason how they are able to degrade such high concentrations of the pesticide. Okay, and later what we did was we took the culture, we inoculated soil sample, we added MCP to the soil, and then we added our bacteria to the soil, and after a week we checked in the soil sample also, we saw that MCP is totally degraded and few harmless products are produced. Okay, text may not be visible to you, but what we want to say here is, so all these 4 bacterial strains work together, okay, and degraded the pesticide finally into just acetic acid or some trisiloxysilane and all, which are harmless for the environment and also for our body. So this is how bacteria can work. So you can understand that they can degrade toxic components into less harmful products. And if we can use the bacterial strains on large scale, this will definitely help farmers, right? So ideally what we should do is use these bacteria, mix them with phosphate solubilizing bacteria like plant growth promoting bacteria, and then apply to large areas of agricultural land so that the organophosphate is degraded and also there is a better mineralization of soil so that more nutrition is absorbed by the plant, because you are adding phosphate solubilizers also. Usually they will act like a fertilizer, phosphate solubilizer. So our next goal is basically to mix these bacteria and make a biofertilizer which will help in bioremediation and also help in it will work in better addition of nutrition also to the soil like a fertilizer. Okay. So these are the conclusions of our work, where we have confirmed that biodegradation by these 4 bacteria, Micrococcus, Rhodococcus, Bacillus and Ochromobacter, is because of genomic and plasmid-borne genes which are coding for enzymes degrading these pesticides, and they are able to degrade this MCP, especially in this study, into harmless compounds like monomethyl phosphate, dimethyl phosphate, acetamide, phosphonacetate, which are finally converted to acetic acid, phosphoric acid, carbon dioxide and water. So this is what is happening naturally, and this obviously has a very big implication that this degradation will help in sustainable intensification by reducing pesticide concentration in the soil, and in future this can be combined with biofertilizers and applied to fields for degradation of pesticide and also retain soil quality. Okay. So this is our lab. So you can see the guy in maroon shirt, he is Ramesh, who has done this work, and we published this in a Brazilian Journal of Microbiology, and when journalists came to our lab, we also put this work on the newspaper, and we were really shocked to see that they really like this work, and several companies are approaching us to ask how we can use this bacteria into the agricultural field. And most surprising thing is, Garikapati Garu, he also mentioned our name, that we have done this work. So even though this is not the main area of work in our lab, we were really blessed to have so much appreciation, and hopefully we will be able to apply this to agricultural fields very soon by collaborating with more number of companies, and hope that in future none of us will get affected by pesticides, because this is a very big menace. We don't realize that, because they affect after 20-30 years of exposure, not continuously. We are exposed to very low doses because of anything, because we wash the vegetables or we try to stay away from outside. We are more at home, we are not exposed to too much of fuel exhaust maybe. But finally you get exposed some or the other way, right? So let us hope that we can handle this issue, and all of us should be in good health in future. Okay, so if some of you start working in this area also, you are welcome to come to us and take our help. Thank you.
Madam, myself Dr. Arif Khan, retired senior professor. I am also having an agricultural sciences background.
Sir.
But my point is, monocrotophos, malathion and floriperiphos, it
Sir.
will be sprayed on the foliar sprays
Yes.
to control the pest.
Yes.
But a very little quantity it will fall on the soil.
Sir.
So instead of that, how your studies in the soil, the monocrotophos, like that. Have you done in the malathion and floriperiphos also?
Yes,
Only
sir.
the
Yeah,
monocrotophos.
we have shown in chlorpyrifos also. But you can see that there is so much contamination in the soil itself. You know,
How it will go? When you apply these granules or dusting,
Sir.
then it will fall mostly on the soil.
Yes.
So we are applying only the liquids, that is the foliar spray.
Yeah.
So monocrotophos 1.6 ml per liter, chlorifier 2.5 ml. So mostly we are concentrating on the plants.
Yes.
So because the pest will damage it. So the monocrotophos is a systemic,
Yes.
and others are the contact.
Yeah.
So my point is how these monocrotophos influence in the soil. That's what.
Yes, sir. So even if we spray on the foliage, lot of it falls onto the soil. Finally, you can observe that also. Afterwards, when they are spraying, you can see because it's just aerosol. There is no control over where it is falling, and many times the crop itself is very short. So they will spray it any time. And because of that, what happens is even after harvesting the plant is also decomposed in the soil. Right? So there are different ways how it can enter soil and also water.
Then my point is instead of soil also you can parallelly test in the plant sample or leaf samples or
Yes,
stalks
yes.
or like this. Then
Yes, yes.
the effect of these organophosphates will be more than
Yes.
soil.
Definitely. So luckily our bacterial strains are sporulating. So they can be sprayed on foliage also. Because they'll be resistant to dying in the dry weather. Yes.
Yeah, congratulations, ma'am,
Thank you, sir.
for this wonderful this thing. I just wanted to know what is your effort in educating the government about it, because you are telling that you have discovered something and you are in touch with the companies.
Yes, sir. Yes, sir.
And you are just thinking about the commercial
Yes,
this
sir.
thing. That's the little bit away from the environmental stewardship, right?
Yes, sir.
So the government should know about it more than the companies.
Yes.
Otherwise, the companies will start, after monocrotophos, they will start selling, okay, if you are taking antibiotic, take this vitamin B12 also along with that, because that will maintain the gut health of your body.
Yes,
So, likewise, if anybody is using monocrotophos, compulsorily he should be given this sort of a thing, that after using the monocrotophos, you have to use this for the land.
Yes,
right?
that is correct.
So, then only you can reclaim the land
Yes, yes.
from the adverse effect of the monocrotophos or any other chemical, as a matter of fact.
Yes, sir. You are
So-
absolutely correct. So there should be more awareness.
No, you are the brain of the agriculture universities. That's what I understand. I told you. I'm
Sir.
a little away from the education and all those
Sir.
things.
Yes, sir.
But the commercial thing is one thing.
Yes.
You are talking to the companies. You should
Yes.
hammer to the government, right?
Yes.
Secretary Agriculture, Secretary this thing, Minister, and all those things. You have to raise this
Correct.
point there at that level.
Yes, sir. Yes.
You are at that level, you have to reach that level. Like, common man, I can't go and talk to the minister that look here, what I am saying that's correct.
Yes,
Right?
yes, yes. Yeah, thank you for the suggestion. Since we are academicians, we tend to, not move outside our comfort zone, but
For
we
me,
are right. We should.
for me, the academicians are something like playback singers,
Yes, sir.
right? So you have to sing the song and the government has to listen to it.
Yes, sir.
right?
Correct.
Yes.
Thank you, sir.
Ultimately, even though you are academic,
Yes,
our
sir.
ultimate recommendation should go the farmer level. What is the just doing research and publishing paper? Then it has to go the recommendation level. You
Yes.
contact with the Department of Agriculture, contact with the Department of Horticulture, university people,
Yes.
like that. Then only the ultimate end user farmers should be benefited, because farmers are concerned with the soil.
Yes.
So that is what you can do it. You should go into the recommendations. You make the observe multiple locations and
Yes.
come to the conclusions in different places. The same results you are getting, you have done in a horticulture experiment.
Yeah, in pot we have done. Yes.
So then you have to do the in field also.
Yes.
Is there any difference between pot culture and field?
Yes.
So is there are another factors, anything they are involved like this? So
Yeah.
this is my suggestion.
Yes. So actually we are in collaboration with Bioenzyme Entrepreneurs. It's an NGO. So we have gone to Nalanda University recently to talk about this. So they are quite positive about working on this together, because Bihar is one of the heavily pesticide using states because they are full of agricultural land. So if you go there, you will find that for hundreds of kilometers, it's just agricultural fields. So they are also having this issue. So they took my help recently. We are in talks with Nalanda University. So hopefully we will start somewhere with this.
Madam, I would suggest go to the Guntur also. We came to soil.
Yes,
Tons
sir.
and tons and lakhs and tons
Yes,
has
yes.
been
Yes.
blended there in the soil.
Yes, sir. Everywhere in India, they
Guntur
ask
is
us.
the pesticide capital.
Yes.
Whatever because I know the numbers, right? I'm a
Yeah.
number guy as far as the commercial things concerned. So whatever was the sale in the Guntur of the pesticides, that was equal to the entire UP 20 years back. That much they were chemicals, they were
Yes, yes.
pesticides, they were pumping in the chilies in
Yes,
Guntur area.
especially chilies. Yes,
Yeah,
correct.
chili. And Telangana
Yes, yes.
farmers also using mango
Yes.
for 60% yes, mango.
Yes, yes.
Chilies and cotton.
Yes, yes.
So in Telangana, the farmers also using more pesticides.
Yes, yes. Everywhere in India, sir, definitely. But they contacted us, so okay, we thought we should help them. So hopefully it will be on a larger scale. Yes, sir. Nalanda University. So these are NGO from Bangalore, bioenzyme and
Thank you.
thank you, sir.
Thank you so much, ma'am. Any more questions from the audience? No more questions. So, on behalf of organizing team, I would like to extend a sincere word of thanks to our speaker, Madam Sandipta, for sharing such valuable insights. We are truly grateful for your time and effort you have taken to join us, ma'am. Thank you so much for the wonderful session. I now invite Supriya of 2nd NZC to introduce our next speaker for the session, Dr. Arif.
Dr. Arif Khan is a senior professor of soil science retired from PJTAU Hyderabad with over 37 years of extensive experience in teaching, research and academic administration. He has served in both state agricultural universities of Telugu-speaking states as well as in premier institutions including the Government of India and NIR DPR Hyderabad, and has also contributed to private academia at Guru Nanak Institute, Rangareddy district. His research expertise spans soil fertility and crop nutrition with a strong focus on rice nutrition, management of citrus iron fluorosis, problem soils, agroforestry, agrobiodiversity, and sustainable management of forestry crops. His work has significantly contributed to improving agricultural productivity and soil health. Dr. Khan has an impressive research record with over 75 publications in national and international journals along with 5 book chapters. He has been actively involved in several research and extension activities aimed at bridging the gap between scientific knowledge and farming practices. He is currently serving as Director of Academics at the Progressive Biochar Society, Hyderabad, where he plays a key role in promoting sustainable agriculture. Through demonstrations, training programs, webinars and seminars, he actively creates awareness among farmers, students and research scholars on the benefits of biochar and eco-friendly farming practices. A recipient of around 14 awards from reputed professional societies and government organizations, Dr. Khan is widely recognized for his contributions to agriculture sciences. He has also participated in numerous national and international conferences, workshops and capacity building programs. Beyond academia, he is deeply committed to social outreach, promoting health awareness and advocating the consumption of wheatgrass juice as a natural health supplement. His works reflect a holistic approach integrating agriculture, sustainability, and community well-being. Little Flower welcomes you, sir.
Thank you. Thank you. So myself, Dr. M. Arif Khan, retired senior professor from Professor Jaishankar Telangana University, Hyderabad. I worked in both Telugu-speaking states, Andhra Pradesh and Telangana. So I retired in 2021 January, 5 years completed. After retirement, so I am doing service in case of Government of India institutions, NIRT, Rajendra Nagar, and private institutions. Now I am also actively involved in the Progressive Biochar Society. I am the academic director, so conducting the webinars and seminars related to the biochar aspects. So before my presentation, just I want to tell about the Progressive Biochar Society. So this Progressive Biochar Society is a registered society and NGO. We are a non-voluntary organization without any profit and loss. And biochar is an environmental concern nowadays because it is a very important, and biochar science become very important, and in future for youngsters to take up the research works on biochar is very promising. So that is why biochar is playing a very important role in environment, crop residue management, soil health, soil improvement, soil quality. Like this, it touches number of aspects biochar. So this Progressive Biochar Society has initiated 2 years back. We have started this society registered in Hyderabad itself. We have the digital office, and since then we are doing the number of activities. So far we have conducted the 7 webinars on different aspects of biochar, inviting the experts and subject experts on biochar expert on the 1 hour webinars. And on 30th March, there is another biochar. I told your principal madam also, if any students are interested, you can register that webinar. And this students we are giving concession only 100 rupees. It is very nominal. So if you are interested to hear about the biochar in the steel industry, how biochar will be useful in the steel industry as a green energy, it is very. Our speakers, 2 speakers, experts are delivering that presentation. So my request to the students, both boys and girls, to register, and we have the flyer of the webinar. I have posted to our principal madam, and in the group also I will post. So then this is the what about the brief biochar society. So this biochar society, just now morning session, our president is there. So he is the international biochar eminent engineer, Dr. N. Sai Bhaskareddy. Our vice president Pramod Kumarji is very much having very knowledge since 20 years pyrolysis. He is very pyrolysis man. So like that, this biochar society is there with very senior persons, engineers, environmentalists, agriculturists, horticulturists, NGOs, like that. So that is why we are all retired persons above 65 or 70. We are concerned about the environment. We have to give the good environment, pure environment to the coming generations. So you people and your generations, coming generations should be safe in this planet. So that is what the biochar plays very important role. So my topic is biomass for biochar, a best choice for soil improvement and quality. So before going to this topic, I want to tell some of these details of the words like biomass, what is biochar, why biochar, what is biochar, how the biochar will be produced. Then what is the soil? Soil is a dynamic resource body. So for the agriculture, it is very important, land and soil. So basically our India is agriculture country, and most of the states are agriculture states. Till now, 65% of the people are having the agriculture as a profession. When compared to the other continents like America, Europe, Australia, their profession is other science and technology, defense, computer science, digitalization, like that. But India, his main profession is agriculture. From this agriculture, we'll get the substantial GDP also, and also foreign exchange by importing the agriculture products like that basmati rice, aromatic rice, spices, condiments like turmeric, chilies, and pepper, like that cinnamon, like that. We have the number of spices which is suitable for the Indian climate, and we are exporting and we are getting the foreign exchange. That is what and most of our employment is also agriculture related. That is sugarcane factories and agriculture related oil factories and fertilizers factories. All these are related. So that is why. And what is the soil? Soil is also this, and day by day the land is also increasing. So the major challenges facing in Indian agriculture, some of the major challenges now we are facing in Indian agriculture are increase in population, and this increase in population will have impact on food grain production also. So now our country, India is the largest population country. Now we have surpassed China also. Now China is the second. India is the nearly 145 crores big population in the world. So for this big population, we have to meet the food grain production and also the buffer stocks and also the surplus stock we need it, because nobody should not be hungry and starving. So that is why food grain is very important. And decreasing the land per capita availability. One side the population is increasing and other side land is decreasing. So land we can't create. So that is why with this limited land availability, we have to produce this food grain production, vegetables, fruits, milk, seafoods, like that. Everything we should come from the this land. And another major problem is global warming, greenhouse effect, and climate change. All these three are interrelated. Global warming. So that is what we are seeing, that the number of our seasons are very erratic, severe cyclones and flash floods, heavy rains, and very too cold waves, and also severe hot summer and heat waves. So these are all these effect of due to the climate change. And deforestation, decrease in this deforestation also, we are cutting the forest because our residential areas are extending to the forest areas. So another one is this decrease in organic carbon content. Decrease in organic carbon content. So now this organic carbon, the average organic carbon in Indian soils is 0.3%. It is very low. Suppose if it is goes very less, then our soil will become inert. So nothing will be produced from this soil if our organic carbon content decreases. It is very low. So the medium organic content of the soils is 0.5% and 0.7% is good, and more than 0.5% the organic carbon is. If the organic carbon content is more in the soil, then your soil is very having more life, and it will be very fertile, and it will be very suitable for all agriculture, field crops and fruit crops. But unfortunately, the organic carbon is decreasing by year. Now it has come to the 0.3%. So another problem is the stubble burning. You are seeing that in and around the Delhi. So the rice fields, after harvesting, they are burning the stubbles. So because of the so many reasons, shortage of labor and the second preparation for the Rabi crop wheat, so they have to prepare the land preparation. So there is a labor shortage. So they are burning these paddy stubbles and straw. So this makes the air quality index very poor. Nowadays we are seeing in the case of telephone, TVs and also in social media. So that is what the stubble burning making the. So another one is the agri waste, crop and tree wood waste management. This is also challenging because just now I told that agriculture is our main profession. So we have the 3 seasons, that is the Kharif, rainy season, and Rabi, winter season, and summer. So during these 3 cropping pattern seasons, we are cultivating the agriculture crops, and we are getting the huge crop waste. So this crop waste management is very difficult, very challenging, and protecting this crop waste from the fire accident and other things also, and composting is also another problem. So this is all of the major challenge. And another one is, just madam told that indiscriminate use of the pesticides and the fertilizers. So more than recommendation, the farmers are applying the chemical fertilizers and pesticides because of the anxiety that if they apply more doses, they will get the more crop production. But it is not. So your soils are polluted and your soils are degrading more than the recommended doses. So that is why biochar is a wonderful material to overcome the problems from serial number 4 to 6 to some extent. Is it out here? So now what is biomass? We should know that because here most of the students are very confined to these words and not touch with these type of words. First I should clarify that what is the biomass. So this biomass is the base for the biochar. So where the biochar will come? From the biomass it will come. So we should know that what is biomass. Biomass is a renewable organic material that comes from the plants and animals. That is from the organic origin. Plants and animals, if they die and decompose, then you will get this biomass. Biomass can be burned directly for heat. Earlier, the biomass is used for burning directly for the heat or converted to the liquids and gases, fuels through various processes for the energy purpose. You are knowing that briquettes and the pellets, if you burn it, you will get the energy. Now our focus is biomass is for the biochar. The biomass resources are renewable organic materials derived from plants, animals, waste produced from this, and forest residues and municipal solid waste and animal. So biochar from biomass. So where will the biochar will come? It will come from the biomass. So this biomass is the plants and origin waste or the agri waste. That is after harvesting you will get the lot of the agri waste. So what is a biochar? Biochar is a rich, highly porous material resistant to decomposition. It produced through the thermal breakdown of plant or animal biomass in a low oxygen environment. It has generated increase in the attention for its agriculture industry. So this is a biochar. So the black one is the coal-like is a biochar. So biochar for biomass for biochar production consists of primarily the agriculture residues, wood waste, animal manure converted via the thermal chemical process like a pyrolysis. Now I will tell that what is the next slide. So biomass as a feedstock. So for biomass, for biochar we need as a feedstock. Feedstock is nothing but any biomass. The common feedstocks include the nut shells, cashew nut shells or the coconut shells, or straws or forestry residues or wood waste with low moisture content being ideal for efficiency. That means these biomass should be perfectly dried. If the moisture content is more, the biochar quality standard will be less. So this biomass should be perfectly sun dried and moisture should be minimum. So the pyrolysis temperatures are typically used to optimize biochar yield and quality for soil amendment and carbon sequestration. So now I will come to the crop residues. India every year approximately generates 500 to 550 million tons of the crop residues annually with the cereals, mainly the rice, wheat, maize and sugarcane and some other crops, accounting for 70% of the total. Major states are the UP, Punjab, Maharashtra and AP, Telangana also. So even after utilizing this biomass for different fields, again 150 leads to this widespread of the crop residues. So these crop residues, protecting is a very problem. If anybody lights or lights that, it will burn out. When you burn it, it will get the smoke or ash, and your pollution, your atmosphere will be polluted. So that is protecting this biomass for the longer period is very difficult. Even Telangana generates approximately 28.89 million tons of agriculture waste annually with 3 seasons with a surplus of 2.96 remaining from the farm level. So even the 7 million tons can be used. So other crop residues are there. So these are the burning, stubble burning, all these. Key residues include the paddy straw, maize stalks, cotton stalks, sugarcane trash, and you can mainly concentration in all districts of the Telangana. So these crop residues, tree waste and residues can be used for some quantity as a purpose of the fodder. This fodder is for the livestock, and mulching for spreading on the soil to conserve the moisture and to control the weeds. And firewood also still some of these our tribal people, agency area, remote people, they are using the crop residues, tree waste as a firewood. And another one is the composting, another one is the manuring. And some crop residues can be used as a animal feed, and briquettes and stubble burning, lastly the charcoal or biochar. So all these lead to one way or other way release the emissions, radiation, and release of the carbon dioxide, carbon monoxide, methane, smoke, ash, particulate matter, resulting pollution in the atmosphere and decrease in the air quality index. So these crop residues, even though you manage for fodder or animal manure, mulching and feed stock, everything, the other things, during all this process, there will be emissions of the carbon dioxide, carbon monoxide, and the methane. If you do the composting, so while decomposing, so these crop residues will be decomposed, they will release this methane and carbon dioxide. They are the major greenhouse gas effect for the global warming. So now what is biochar? So biochar is a special material which is created when a biomass like crop residues, wood, manure is heated at a temperature 300 to 500 degrees without oxygen or limited oxygen. So the biochar means the burning these crop residues at a temperature 300 to 500 in the absence of the oxygen and limited conditions of the oxygen. That is called, the process is called as a pyrolysis. So biochar is a black gold when enrich the soil. So now why biochar? For agri, crop, tree, wood management to wealth. So from waste to wealth, to stop the stubble burning, which is a problem and major challenging and environmental concern. Global warming, greenhouse gas effect and climate change mitigation. So this biochar is required. And soil carbon sequestration. That is, soil carbon sequestration means in the carbon carrying over effect. So where the carbon will go to the soil, so this carbon will come from the atmosphere. You know that all these your studies, you know that photosynthesis. So the carbon photosynthesis are in the form of carbohydrates. So this carbon dioxide in the presence of sunlight and as water, you will get the photosynthesis. So the carbon is coming from, and again these plant residues will decompose, the carbon is going to the soil. From atmosphere to the soil, the carbon is going to the soil. So that is the carbon sequestration. And for better soil environment and soil biodiversity, soil health and quality improvement. So above ground we are worrying about the biodiversity, but you should also worry about the below ground, that is inside the soil also biodiversity is there. Soil environment is very important because beneficial microorganisms, bacteria, virus, fungus and actinomycetes, protozoa and earthworms, termites, insects, like this many beneficial insects and microorganisms are present in the inside the soil. So that is why soil biodiversity is also very important. Biochar added fertilizers with the co-composting. So biochar added fertilizer is very important because biochar as it is not useful for soil application or soil amendment. It has to be compulsorily co-composted with any organic materials or manures or bioinoculants. Then only it can be used as a soil amendment or soil application. So directly biochar is again, it is a coal. It is can be burned and used as a fuel. For overall sustainability agriculture, the development goals, the biochar is required. So biochar is for sustainable agriculture. So this is the electronic scanning microscope of the biochar. Suppose if you see the biochar nanoparticles, it will be like that. It will be highly porous. it will have the more microporous. That is why biochar is very light in weight and it has a more micropores. That's why it will absorb the more water, and biochar will invite the habitats of the microorganisms in the case of in this micropores. So that is what the biochar, when you see this under electron microscope. So you should not confuse with the biochar and charcoal. We have the two words we are using, biochar and charcoal. There is a little difference. Charcoal can be used as an activated carbon, but biochar is a soil amendment. So you should know that what is the difference means. It is specially used in improving the soil health. Biochar can be used for the improving the soil health, whereas the charcoal it is used for heating, that is burning. We are using that now boilers and the dobbies and also when industries boilers heating we are using as a fuel. That is the normal charcoal. So biochar is a more porous sponge-like structure as I seen in the electron microscope, and the charcoal is very less porous, not spongy. So the temperature here are very high, 300 to 560, and whereas the charcoal produced at a less temperature, 200 to 300, and biochar it will take less time, whereas the charcoal it will take more times, that is weeks or the more than the fortnight also. Charred biochar as a soil amendment in agriculture purpose, and charcoal is mainly for fuel, energy and burning purpose. So the surface area of the biochar is more. So whenever the particle size is less, the surface area will be more. Then these nanoparticles are very active, whereas the charcoal particles are less surface area. So more surface area is the advantage of the biochar. So the biochar has the multiple uses. In various aspects we can use the biochar. So it can be used as a biogas industry, that is steel industry, sanitation and cosmetics, even in case of the gels and the ointments and the many cases of creams, cosmetics, medicines and high technology and the construction, that is in the bricks also you can mix with the biochar. So it will be locked. So our aim is the carbon should not come into the atmosphere. When it comes into the atmosphere, the carbon dioxide concentration will be more. That is what now worrying. Now the present concentration of the carbon dioxide is 390 to 400 ppm. It has increased drastically during this last 50 years. So once this carbon dioxide will increase more in the atmosphere, then we are facing the global warming, and the average temperatures is increased 1.5 degrees centigrade. So this is what mainly due to the greenhouse gases, and among them the carbon dioxide is the biggest culprit. So construction material, once you mix this biochar into the bricks and this, it will be in the bricks for so many years. And food material and livestock, even animal feed also biochar can be used, and agriculture we have already told that. So this is the various fields the biochar can be used. So biomass as a feedstock, so there is a wide adaptability. So for biochar can be produced from the various feedstocks. So whatever the waste present, like animal waste, industrial waste, sewage floods, even in Greater Hyderabad we have a problem with urban sewage floods. These urban sewage floods can also be used for the biochar, and wood chips and food waste, agro waste, forestry waste. So this is what the biochar, by the pyrolysis process the biochar will be produced. So during this biochar process, in high technology methods, we will get the three products: solids as a biochar, liquids as a bio oil, and gases as a syngas. So this is what the under biochar production will have. But at a farmer level and artisanal traditional method, we don't get this any bio oil and syngas. Only we will get the biochar solids. So this is the recovery of this biochar from the 100% of the feedstock, nearly the 30%, and the 20% syngas, and the remaining is the bio oil and wood vinegar. So three industrial products all can be utilized for the energy purpose or fuel purpose and soil applications. So biochar charging and application. I told that biochar as it is we should not apply into the soil. So it has to be charged. That means like a mobile phone we will charge it to get the energy and power. So once you charge this biochar, then it will be charged biochar. Then only you have to apply as the agriculture application for the any agriculture crops or the horticulture crops. So this charging, we should know that it should be mixed with any organic materials. So we have the number of organic materials like organic manures or sheep manure, poultry manure, or organic the bioinoculants, cow dung and cow urine, like that we have the number of organic solutions. So once the biochar produced is there, it has to mix 1:1 ratio and keep it for the 2 weeks for as an incubation period to get the develop the good properties of the biochar for the soil application. So once you mix this with any organic materials as a co-composting, after 2 weeks you can apply this biochar, then we will call it as biochar added fertilizer. Otherwise, once only the preparation of the biochar is not enough, we will not apply to the soil. So that you have to see. So this is the charging of the biochar is very important. So the effect of biochar plants is a profound influence even on monocotyledons and dicotyledons. You see that the water use efficiency will be increased, chlorophyll content will be increased, transpiration will be increased, root biomass will be increased, and photosynthesis also increased. So all these have the beneficial effects, root biomass. So everything has the good positive effects. So this biochar, when you apply to the any plant species, either monocots or dicots, it will have the good beneficial effect. So this is the biochar cycle. So how this biochar? So first we have this photosynthesis process where the biomass will be produced in the presence of sunlight and carbon dioxide, and this plant will prepare the photosynthesis, and this after that this dried biomass, then it will be we can prepare with the biochar with the process of the pyrolysis. So this once this biochar will apply, the carbon and nutrient available nutrient status in the soil will be increased. So then this crop production will be good. So this is the biochar cycle. So now we have to, because our topic is a biochar, a best choice for soil improvement and soil quality, we should know what is the soil. So because here the soil is very important. The soil is a dynamic and 3D natural resource. So this is a profile. What is soil profile we call it? When you dig this soil any 1 meter depth, we have the number of layers. So the arrangement of these soil layers is called as the soil profile. So soil is a dynamic natural resource, is the biologically active and porous top layer of the earth crust, forming a functioning foundation of the terrestrial life and agriculture. It is a complex living mixture of weathered rock minerals. So the soil is formed after thousands of years from the weathered rock materials. So how these rocks will come? These rocks will come from the volcanoes. So the molten lava when erupts from from underground or the hills or mountains, then the molten lava liquid will be solidifies and then it will be rocks will be formed. These rocks and boulders, after several thousand years, you will get the soil. So that is why soil is very important, and it has both the inorganic material and organic material, and it is the storehouse of the nutrients or the elements, water, air, and this. So this soil supports the plant growth and filters water. For growing demands of the agriculture production, decline in soil fertility is problematic. Now our soil's fertility is decreasing day by day because of the so many reasons: management practices, excess use of these chemical fertilizers, agri inputs, pesticides, and also the climatic factors, everything. Now the soil fertility will be decreased. Once your soil is poor, means your crop growth will be poor and your production will be less. So the excess use of these synthetic fertilizers and monocropping has harmed the soil health and quality. So in the Telangana it is happening that monocropping, because the farmers are mainly cultivating two major crops, either rice. If they are having 10 acres, they will cultivate only rice. If they have 10 acres of dry land, they will cultivate cotton. So this monocropping also will decrease the soil health and quality. So under these conditions, biochar application can improve the soil properties, but its effectiveness is based on the category of the biochar, soil type, and application rate. That means, so the quality of the biochar depends upon the feedstock, and the way of the procedure we have followed, the pyrolysis and the temperature methods, all these things, the quality and standard of the biochar will be effect. So the soil type, so black soils, red soils we have. So depending upon the soil type, the response of the biochar is different, and application rate. So for all soils, the application rate is not uniform. For a horticulture crop, fruit crop, field crop, the application rate is different. So definitely biochar improves the soil properties. So like any object, we have the properties. Soil will also have the properties like physical properties, chemical properties, and biological properties. If all these properties are good, then your soil is called as a normal soil or good soil. So if there is any problem in chemical properties, so it is a disadvantage. If there is any problem in case of physical properties, then it is a problem. So like this, a normal soil should have all three properties in a good conditions. So definitely the biochar definitely improves their soil properties. So this is the what enhances the plant growth and also the increases the microbial respiration, improve the soil enzyme activity and increase the soil pH and improve the soil health, porosity, water holding capacity and carbon sequestration. So all these things will done by the biochar. So now we will go to the biochar as a soil amendment and its effect on the soil physical properties. So in this number of physical properties we will have, but I will touch with the important soil physical properties like porosity, that is aeration, and bulk density. So these are the important properties. How, if you apply the biochar in the soil, what will happen? So how it happens, I will present. So now this is because these are all these review articles. I have taken the information because we are all the retired professionals. We have not done the original research of the biochar. So whatever this literature available and whatever these papers available, we have compiled and taken the review of the biochar and how it will affect the soil porosity and surface area. So porosity is very important. Porosity means aeration capacity of the soil. Because I told that inside the soils number of organisms, microorganisms and macroorganisms. Microorganisms, they are not visible, like bacteria, virus, actinomycetes, like that. Macroorganisms, earthworms, termites, insects, and a number of things, grubs and ants are there. So they need oxygen inside the soil. So porosity means good aeration capacity. So this is very important. Suppose if the soil is porous, then you will get the good porosity for the microorganisms. So these microorganisms will do the lot of the beneficial and the good things for the nutrient availability. So this is the Mukherjee and Lal et al. Reported that high soil porosity was due to the porous nature of the biochar. So once you apply the biochar to the soil, your soil becomes porous. Because biochar itself is having the highly light material and porous, then that's definitely if you apply the soil, biochar to soil, it will porous. So next to the Chen and Yuan and Gulel et al., they reported that large surface area improves the number of microbial activity and root growth in soil pores and increase the microorganisms in the soil. So that is what these co-authors will reported. So once you apply this, biochar is having a large surface area. So once you apply the biochar powder in the form of the soil, then your soil porosity will be increased and it will be very good habitat for the microorganisms. Addition of biochar significantly enhances the soil porosity permeability. Permeability means water infiltration, we call it as a permeability. So whatever is water present, it should not be stagnated, it should be permeable, it should be filtered and water conducting capacity. So next one is another important is the bulk density. Soil will have the two densities. One is the particle density, one is the bulk density, another is the particle density. So particle density is not important for the soil because particle density is a constant for all the soils in the anywhere you have to take in the world. The particle density of the soils in different countries or different continents, it will be 2.65 as a common factor because the particle density is mainly the composition of the mineral matter, that is elements present in the soil. But only the bulk density will be very important because it influences with the management practices, application of the manures, everything. So bulk density for the soil is very important. What is bulk density means? Mass volume is the density, and this bulk density means this is the mass of the soil including the voids, that is volume of the pores, that is what the bulk density. So if the bulk density is more in the soil means your soil is very hard. if the soil is hard means your soil is compact. Then if the soil is compact and hard, the root penetration is very difficult. So that's why the soil should be porous and your bulk density should come down. So once you apply the biochar, your bulk density will be come down. So these are the Mukherjee and Lal et al. Also reported that according to the study, the use of the biochar reduces the bulk density of soil because biochar is a highly poriferous and when applied to soil reduces the bulk density by increasing the pore volume. And Pandin et al. Also reported that application of biochar to soil decreased the bulk density. For example, the red gram stock prepared as a biochar applied at the rate of 5 tons per hectare had a lower bulk density 1.36 and a wide space is fixed than the control. That means our control plants are having 1.5 bulk density, that is grams per cc, and when you apply the red gram stocks at the rate of 5 tons per hectare, then your bulk density will come down. That is a good indication of this good physical property of the soil. So that is why biochar is very useful for the decreasing the biodensity, bulk density. So this is another report that the soil at the rate of 40 tons consistently lowered the soil bulk density from 1.0 to 0.89 grams per cc compared to the control. That means decreasing the 0.01% is also very important. So that is why the soil is having a come down from this to this. So this is reported as Zhang et al. 2012. So next the chemical properties. So soil will have the chemical properties. So the biochar will have the good impact on the chemical properties, like if you apply the biochar, reduces the acidity, retain the nutrients, and it is increase the acidity in case of the acid soils, improve the soil fertility, increases the availability of the NPS, that is the major nutrients and secondary nutrients, increases levels of the cations, calcium, magnesium, and nutrient use efficiency, that is your fertilizer use efficiency will be increased if you apply the biochar, and it also mitigates the hazardous effects of the pesticides. So if you apply any pesticides, it will be persistent for long period in the soil. So then this biochar will mitigate the hazardness and excess fertilizer and lowers the heavy metal pollution, bring them to below toxic levels. So heavy metals in the soil is also very important. Heavy metals means like the cadmium and nickel and cobalt, mercury, all these are the heavy metals. If their concentration is more, then it is we will enter into the plants and again it will enter the human body chain. Then it is impact on the body health, human health, that is heavy metals will damage. So biochar application for acid soils. So one of the property of the biochar is biochar after prepared, if you test that biochar for the pH, it will have the more than 9. You know that all students pH scale is a 0 to 14. So the biochar originally when it is prepared it will having the 9. So the high pH is somewhat not desirable for apply the neutral to the alkali soils. But this high pH biochar is useful for the acid soils, because in acid soils acidity is a problem, hydrogen ions is the concentration. So once you apply the biochar having the high pH, your pH in the acid soil will be increased. In case of the Telangana, or we have the acid soils like the Zahirabad, Sadasivpeta and the Sangareddy district acid soils. So under this acid soil biochar application we give, because in the acid soil we have to increase the pH, we have to bring to the neutrality. So that is what the major advantage. And biochar as a carbon sequestration. So I told that the carbon sequestration coming from the carbon cycle, so inside the carbon will be more. Biochar as a long-term carbon sink which lowers the greenhouse gases. So biochar acts as a carbon sink to lowers the greenhouse gases and mitigates the global warming as said by the Kalantinal and Fahad et al. So this is what this biochar effect on chemical properties, soil pH. So the first in the soil sample testing we will do the pH. So in case of the human being, what the physician will test your nerve and heartbeat like that. For any soil, the first property, basic property will see the pH. So once you know the pH, then we can tell that your soil behavior and nutrient availability and that. So the pH is very important and it is a basic property. the pH of the soil will basic property, while soil genesis only the properties will develop. We can't catastrophic suddenly change the pH. So that is why pH is a very important basic property. Once you know the pH, we can know that. So these are the effect on the biochar application. Will have the applying the 10 tons of biochar raises the acid soil from 4.6 to 5.7. So here it has increased. So that is a good thing in case of the acid soils, because in the higher acid condition, aluminum ions are more problem in case of the acid soils. So this is what the good thing the biochar on the acid soils doing. And the cation exchange capacity. Another one is the important chemical property of the soil is cation exchange capacity. That means the capacity of the soil to exchange the cations. Most of the nutrients are cations like ammonia, NH4, and calcium, magnesium, and potassium. All these are positively charged elements are cations. So if your soil is having more cation exchange capacity, then your soil is good and your nutrient availability, nutrient retention will be more. So if you apply the biochar also, the cation exchange capacity of the soil will be increased. So that is what the good thing will do. So here you see that adding the biochar to soil biomass, the total CEC will be increased 20 to 40% from the control. It is good thing. And high CEC soils are better absorbing cations like ammonia, calcium, magnesium, and which improves the nutrient efficiency. So all cations are our nutrients. Plant needs 16 nutrients to complete its life cycle. Major nutrients, secondary nutrients, and micronutrients. So last one is the biochar application and biological properties. I told that physical and chemical properties other than the biological properties of the soil is also more. What is the biological properties means? The capacity of the soil to have the microorganisms population will be more, or earthworm population or humus content. If they are more, then the biological properties of the soil will be good. So this application of biochar will influence the microbial respiration, because the soil microbes will help the nutrients to bring the solubilization and transporters. So most of this bacteria and fungus, they will make as a solubilization of the nutrients, that is the elements. Suppose in the soils, the potassium will be there, it will be fixed in the soil, but it has to come into the soil solution, and phosphorus will be in the soil, it will be fixed form, it will not available. So these microbes, they will solubilize or transport. For example, the mycorrhiza, that is a viscular or arbuscular mycorrhiza, when fungus is there, it acts as a transporter. That means it brings the nutrients like phosphorus, zinc and iron to the nearest to the root surface area, that is a soil solution. That is what the good thing inside the soil microbes they are doing. So once this our soil microbial population is good and multiplication is good, then the biological properties of the soil and it increases the soil biodiversity in the presence of the organic carbon and increases the microorganisms and improves the aggregation. Soil aggregates also very important. And so, for example, the microbial integration. So biochar can be used as a carrier for the inoculation of the microbes. Earlier we are using as a lignite, vermiculite, perlite. So they are all the industrial or the some other waste product. Now the biochar can also can be used as a carrier for multiplying the microbes. That is what, because biochar is having the good properties like light porous material, and also it is a sponge-like structure. So that is it will be very good for these microbes like rhizobium, azotobacter, trichoderma, bacillus, azosphyllum, pseudomonas, glomus. So all these microorganisms will present inside the soil. They will do as a nutrient solubilizers and fixers. Rhizobium bacterium is very useful for fixing the atmospheric nitrogen from the atmosphere to the soil. So that rhizobium will do that. So nitrogen as a gas is not at all useful for the plants. It has to come to the nitrates or the ammonium form. Then that part will do this rhizobium bacteria. So once your soil is having more rhizobium bacteria, then the nitrogen fixation will be more, and nitrogen is one of the major nutrients for the plants. So, and it also lessens the termites crops and more number of earthworms. So these earthworms are two types in the soil. Some earthworms will depend upon the food as the soil particles, and other earthworms they will take the food as the organic matter. So that is what if you apply this biochar, your rhizosphere or the soil environment will be very congenial for the microbial population. So this is the now I will sum up this presentation what we have done. So biochar added fertilizer co-compost application can improve soil properties, quality, environment, biodiversity, but its effectiveness is based upon the category of the biochar prepared, soil type and application rate. Biochar made from various raw materials, hence it is environmentally prepared from the various biomass, hence it is environmentally eco-friendly and can be used in soil and water applications. Modified soil element is applied for agriculture, horticulture or forestry crop for increasing the yields and production. Biochar has augmented the degraded lands and salt affected soils. So now our problem is soil degradation is very problem, and also salt affected soils are there. So for these degraded soils and salt affected soils, biochar application definitely improve the soil properties and increase the soil enzyme activities. So inside that the soil microbes they will release enzymes. So if the soil is having good soil enzyme activity, then they were nutrient availability will more and facilitates soil organisms, microorganisms growth and improve the soil chemical process, increase the agricultural production and reduce the greenhouse gases. So the main important is biochar, a best choice for soil improvement and climate change mitigation. Biochar reduces the offset the pollution by increasing nutrient retention and decreasing nutrient leaching. Research on biochar used in soils has augmented and is expected to be sustained due to its multiple benefits discussed in this. So this is the word. Thanks for your attention. Our aim is save the planet, save the planet. So youngsters, you have to protect this environment. You have a lot of future, and your shoulders, you are on the shoulder that's environment. This is very important because we are living in this environment. So once this environment is cool and pure and without pollution, then our survival is good. So that is what. Thank you very much for giving this opportunity for the organizers. Any doubts? Students are not asking any questions. So they should ask some questions because the new topic when you are hearing means this. In future the biochar science become very valuable, and also it is very important. So you can select for your research program and PG programs and PhD program biochar experts. You have a lot of good placement and career. Those who do the research on biochar experts, they will get good opportunities industries level or the computer level also, because the biochar another is by producing the biochar pyrolysis we will get the carbon credits, carbon trading. That is also another topic I have not touched because my focus is mainly on the soil improvement and soil quality. That's why. So you put some interest on biochar science. Okay, thank you. Is any questions?
Good afternoon, sir. I'm Pranita from Government City College. My doubt is, if a crop lasts for 6 months, then how many times we need to add this co-composter with fertilizer?
So co-composting is very important for biochar. So once you prepare the biochar from any feedstock, any biomass, so then you select any organic materials, whatever you apply, either farming manure or animal manure or this vermicompost, you mix it. Because originally the biochar pH will be more, we have to bring it because it will be more than 9. So that high pH biochar is not recommended as it is. So that's why we have to bring down. If you apply these organic manures, and we call it as incubation period, that is a mixing in 1:1 ratio. Suppose if you prepared 100 kg biochar, you mix with 100 kg of any manure or vermicompost, keep it for 2 weeks as incubation period to attract the microbes, because in the air so many microbes are there. So you will get that, because biochar is like a sponge material and also like a porous material. So while mixing this organic material, just you sprinkle the organic, the jaggery solutions also, because jaggery will get this energy for microorganisms as it is a sucrose or next thing are there. So you sprinkle some of the jaggery solutions and keep it for 2 weeks as a heap. Then this then the biochar properties will be still improved. Then it will be very congenial for application of this. So you keep that in mind, and after co-composting only you apply to the biochar to the any soil or plants also, pot culture, nursery or lawns, anything you can apply it in powder form.
Thank you, sir.
So now the biochar can be manufactured by Newsweed seeds. Newsweed seeds limited are there. They are prepared in a biochar with high technology, and they are getting the carbon credits and they are doing the carbon trading. So in addition that to get that carbon credits and carbon trading, now they are giving this biochar very free to the, whenever you approach the Newsweed seeds here in Hyderabad, you go through the website and their contact number, they will give freely whatever you need, 1 ton or the 2 tons, anything they are giving biochar. And other NGO organizations also there in the Aranya, agricultural organizations like the Hyderabad, one NGO is there, they are also preparing. Now biochar is available, you can go through their website. So why they are giving the free means, they are getting carbon credits at international level, because they are not emitting any radiation and emissions. For that, they are doing the good to the nature, and they are locking the carbon. So here in case of the biochar, the carbon will be elemental carbon, it will be fixed. So that is what the things. So when they will give the carbon credits, carbon days, once this biochar only apply to the soil, then only they will get. Suppose if you prepare the biochar, keep it at is you don't get its carbon credits. Once it is go to the soil only, then the carbon, elemental carbon goes into the soil and fix into the soil. The life of the biochar will be more than 100 years. If you apply the biochar to the soil, the elemental carbon will be inside the soil longer. So that is what you can approach the Newsweed Seeds Limited. Thank you. If there are no questions.
Now, question that how much biochar will apply to per acre, how much has to be applied?
Sir, it depends upon the type of soil. Suppose if it is black soil, its behavior is different. Suppose if it is red soil, its behavior is different. And another is the type of the crops you selected. Suppose field crops, you have to apply the broadcasting. For horticulture, fruit crops, you have to apply to the trees, plant basins. So it depends upon 1 ton to the 4 tons per acre. Before that, you can test that soil testing in the soil testing laboratories. Then you can know the status of the organic carbon and other nutrient status. Then you can decide the application rate. So depending upon your soil type, your biochar quality and your crop selection, then it will differ. The application dose will be different. Thank you, sir.
Any more questions? Okay. On behalf of the organizing team, I extend a vote of thanks. We are really delighted to hear your session, sir. It was so good. We have come to know about what is biochar and its applications, how we can use it, and what research can be done. Thank you so much for your insights, sir. And the lunch is ready. After that, we'll be continuing with 2 sessions followed with offline presentations. All of you, please join for the lunch. It is in the next hall. Thank you. Lunch break is till 2. Please come back by 2 o'clock in the same hall. Thank you.